Once again, I welcome all the B.Sc. third year Analytical Chemistry student to our online lecture. So, in yesterday's class, we have learned about the different instrumental part of the IR spectrometer. So, today we are going to learn about the proper instrument, that is what single and double beam spectrometer. So let's begin with the single beam spectrometer. So student friends, a single beam infrared spectrometer is shown in the given figure. It is what the source of light, slit, monochromator, then the sample cell, chopper, entrance slit, aluminized concave mirror is there, and what the entrance slit as well as alkali halide prism and rotating litro mirrors are there for the for the purpose of what the reflection of the beam. So an optical diagram of a single beam infrared spectrometer is systematically shown below. Then see how this another one is a block diagram of the single beam spectrometer. The light source, then chopper chop the beam and get the constant intensity of the light, then sample cell, flame furnace, and monochromator and detector. In the single beam IR spectrometer, the radiation from proper IR source are confined by a slit and then allowed to pass through the proper alkali halide sample cell. Then the transmitted beam is then chopped by means of slotted disc copper rotating at a speed greater than 600 revolution per minute. The chopped beam then passed through the entrance slit, the width of which can be adjusted, and falls on aluminized large concave mirror, which reflects the beam towards a fixed alkali halide prism. The beam is refracted onto the surface of the rotating litro mirror. Then the function of this mirror is to fold. It reflects beam back to the fixed prism and focuses it on the upper portion of the fixed prism. So these the twofold action of this rotating litro mirror, that is what it reflects the beam back to the fixed prism and focuses it on the upper portion of the fixed prism. The beam is refracted and dispersed a second time through the same prism. Thus, both the alkali halide prism and litro mirror select the desired wavelength and serves the purpose of a monochromator. So, the different wavelengths of IR radiation reflected second times from surface of the same previous aluminized concave mirror in the direction of the IR detector. The intensity of this beam is adjusted by exit slit, and after receiving by the detector, the radiant beam produces a transduced electrical signal which is amplified and recorded. The utility of the chopped beam is that the electrical signal obtained has the frequency of the chopper with appropriate circuitry. This signal is radially separated from the extraneous radiation signals, which ordinarily do not change much with time. So the detector signal gives the intensity of the IR radiation after it passes through the sample. Knowing the original intensity of the radiation without sample, one can calculate percentage transmittance. So by knowing the percentage transmittance at different wavelengths, the IR spectrum of the sample can be obtained. So This is about the what the working of the IR spectrometer. See what happened when the that source then see what happened. This IR source here, what the radiation from the IR source, that is here IR source is there. From the IR source, radiation uh, go through this slit, and slit what they concentrate the beam, and it falls upon the sample cell, and from sample cell it passes. This beam is chopped by means of the chopper, which is what the having the rotation about 600 per minute rotation is there for the what getting the intense beam. Then this beam, chopped beam, is passed through the entrance slit, and it fall on the aluminized concave mirror. Then this beam is reflected towards through the prism, that is what prism monochromator, and then after passing through this monochromator here, it falls on the litro mirror, rotating litro mirror. What it has the twofold action, that is what rotating mirror what happens, it reflects the beam of radiation, and it focuses the beam to the upper position of this mirror, that is what the prism, and it the after what refraction after reflection of the beam from this litro mirror, it falls on the prism, and it passes through the prism, and will get the desired wavelength of the light, that is what the monochromatic light. And after that, it falls upon the aluminized concave mirror, and refraction of the light takes place. After refraction, the light passes through the exit slit, and this light is detected by means of the detector. So this is the overall working principle of this single beam infrared spectrometer. Then this transmittance is measured by means of the spectrometer, and with the help of transmittance we can able to what get the single beam infrared spectrometer, that is what the IR spectrum from this detector, IR detector. So once again we see in short how this work. When light source passes through this passes through the slit, and then after that the light is passes through the sample, and after passing through the sample, this beam is transmitted beam is what is chopped by means of chopper with the rotating speed is about what 600 per minute. And after this chopping this beam to get the intense beam, then this beam is passed through the entrance slit, and it falls upon the aluminized concave mirror. On this mirror, this beams get reflected towards the prism, and it passes through the prism, and after falling on the rotating litro mirror has a twofold action, and it reflects the beam, and it what concentrate the beam, and it passes the beam what the upper portion of the what prism, through the upper portion of prism, and after transmit this beam is passed through this prism, will get the monochromator. So this litro mirror and this prism acts as an monochromator, and will get the desired wavelength light, and this falls upon the aluminized concave mirror, and after reflection of this ray, and this beam passes through the exit slit, and after what coming out, it falls on the detector, and detector what measures the beam, that is what the whatever the beam is transmitted, and this transmittance is nothing but after what measuring the transmittance we will get the uh, actual spectrum of that is IR spectrum. So see what is the in the single beam IR spectrometer, the radiation from proper IR source are confined by the slit and then allowed to pass through the proper alkali halide sample cell, and then the transmitted beam is then chopped by means of the slotted dish, that is what the copper, rotating at a speed greater than 600 revolution per minute. The chopped beam then passes through the entrance slit, and the width of which can be adjusted and falls on the aluminized larger concave mirror, which reflects a beam towards the fixed alkali halide prism, and the beam is refracted onto the surface of a rotating litho mirror. Then the function of this mirror is twofold. It reflects beam back to the fixed prism and focuses it on the upper portion of the fixed prism. The beam is refracted and dispersed second time through the same prism. So because what? Two times it dispersed from the prism. Thus both the alkali halide prism and litho mirror select the desired wavelength and serves as a monochromator for the single beam. Then the detector signal gives the intensity of IR radiation. The purpose of monochromator, then the different wavelengths of IR radiation are reflected second times from the surface of the same previous aluminized concave mirror in the direction of the IR detector, because first time it is not get dispersed through the prism, so it has the different wavelength and different than the second time dispersion. So two times reflection takes place on the reflection takes place on the concave mirror, aluminized concave mirror, and it is passed through the detector. The intensity of this beam is adjusted by the exit slit, and after receiving by the detector, the radiant beam produces a transduced electrical signal which is amplified and recorded. The utility of the chopped beam is that the electrical signal obtained has the frequency of the chopper with the appropriate circuitry. So this signal is radially separated from the extraneous radiation, that is what the foreign radiation signals, which ordinarily do not change much with time. So after the detector signal gives the intensity of the IR radiation after it passes through the sample. Knowing the original intensity of the radiation without sample, one can calculate the percentage transmission. By knowing the percentage transmission at different wavelengths, the IR spectrum of the sample can be obtained. So this is about the working of the simple single beam spectrometer. What are the disadvantages of this single beam spectrometer? The intensity of the IR source varies from time to time with the natural fluctuation in the source. Therefore, the resulting spectrum is considerably deformed. So what happened? This is the first drawback or disadvantage of this single beam spectrometer. Will not get the constant source of IR radiation. Will get the fluctuation in the intensity of the IR radiation. So we'll get the deformed spectra. And second one is when the sample is analyzed in the solution, the bands of the solvent appear in the spectrum. So this is the another problem. Instead of getting the bands of the sample, we will get the spectrum of the solvent. So here